Everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on determining the magnetic susceptibility of a given liquid using Quinke's method. So here are the apparatus required to do this experiment. So this is the Quinke's tube where we have to keep the MnSO4 solution. So we have to keep this Quinke's tube between the magnetic field. This is the narrow tube. You can see we have kept between the magnetic field. Traveling microscope to note down the level of the MnSO4 solution in the Quinke's tube once we apply the magnetic field. And here is the DC power supply. So we have to apply the current with the help constant current power supply. So this borosilicate glass consists of a framework of borosil glass tube with side tube and narrow bore beside. Thus there is a funnel attached to it to facilitate the falling of the given solution. So to start with Quinke's tube that is thoroughly cleaned with a hot solution chloric acid and then rinsed with double distilled water. Then tube is dried in hot air oven. The dry tube taken and filled with solution of a paramagnetic salt. The Quinke's tube is now placed in magnetic field produced by electromagnet such that the narrow limb is at the center of the pole piece. The meniscus should meet the middle point G at the pole pieces. The meniscus is seen through the traveling microscope. The position of the meniscus measured on the vertical scale of the traveling microscope. So with the help of diagram also you can understand. Here is the Quinke's tube with a paramagnetic solution MnSO4 and this is the narrow tube which is kept between the electromagnet, and here is the level of the solution. Meniscus you have to observe with the help of traveling microscope vertical scale reading, and this is the U-shaped tube, Quinke's tube. So if you want to note down the total reading, you require least count of the traveling microscope. So smallest division on main scale, number of divisions on vernier scale. Once you note down, you can calculate least count. It is 0.001 centimeter. So you can calculate the level of the meniscus, that is using total reading MSR plus CVD into least count. So the given liquid solution normality is 4N. So here is the tabular column, concentration of solution, current in ampere. You are applying with the help of constant power supply. Magnetic field H, you should note down. Liquid level, that is H in centimeter. H naught you have to take for the 0 applied current, and remaining you have to take H1 up to H5 for the applied current 5 milliampere and the corresponding magnetic field. Take the difference, that is given by H equal to H naught minus H. So you have to subtract the values of H1 to H5 in H naught. You will get the value of difference in level H. Then take the square of this magnetic field. So once you calculate, go for LSF method. Consider H square as Xi, H as Yi, and calculate the LSF parameters P, Q, R, S. You can calculate the slope and intercept. Once you calculate, so X1 and X2 value you have to calculate. For X1, so here the minimum value you have to take x minimum 0.722, and the small value you must consider less than 0.7, so that is 0.5 here they have taken. So calculate x1, x minimum minus small value. Similarly x2, that is x maximum plus small value. So here maximum value is 43.56 and the small value same here 0.5. Add and you will get the x2. Once you calculate x1, x2, calculate y1 and y2 by substituting values of x1, x2 and slope intercept. This is the graph of h versus h square. So you have to consider here the x1, y1 values and join the line. So that must be a straight line. Magnetic susceptibility you can calculate, that is given by psi equal to 2g into slope of h versus h square. Slope you have to calculate from graph. So g value is gravity, that is 9.8 meter per second square, or in terms of centimeter 980. Calculate the susceptibility. Atomic susceptibility you can calculate by substituting magnetic susceptibility and atomic weight of the given solution. Then molecular susceptibility, psi into molecular weight, and then effective Bohr magneton, that is given by the equation mu E is equal to 2.82 into root of xa, that is atomic susceptibility into temperature, room temperature. You have to substitute here in terms of Kelvin. So at the end you can write the result by putting the values of all the parameters: magnetic susceptibility, atomic, molecular susceptibility and effective Bohr magneton.